So JSON can be a lot slower compared to other protocols. So for example, in here, we've got JSON ranking the third compared to two other protocols like the protobuf or the AVSC in here. And JSON isn't actually doing that great when it comes to performance, when it comes to JSON parts in here for deserialization. Or for instance, if you pick up the serialization part where you use JSON stringify is like third one in the list compared, to the two first in here, the protobuf again, and the AVSC. And that makes JSON a lot slower. So let's go ahead and find out why. So before we get started, we need to know this disclaimer before we continue with the rest of the video. So TLDR, JSON is literally the best data interchange format for sending and receiving data between a client and a server over the web. Period. So particularly in this video, we will delve into the precise reasons why JSON can pose challenges for your applications and, more importantly, explore strategies to address these issues. It's important to note that, our intention is not to undermine JSON, but rather to comprehend its limitations and find ways to optimize its performance for faster and more responsive applications. So JSON is great. We all love JSON. I use JSON every single day, but in this particular video, I'm just going to see why JSON is slow and what might be a better alternative for different types of applications that you may work on. So before we jump into why JSON is slow, or before benchmarking JSON versus other protocols, we first gotta need to know exactly what JSON is and why it's pretty much everywhere around the web, JavaScript. It's literally used everywhere. So JSON is a lightweight data interchange format that obviously has become the go-to choice for transmitting and storing data in web applications. Of course, because of its simplicity, human readable format, and because it actually makes it super easy for both humans and machines to work with the JSON format. It doesn't take a lot of overhead, it's very easy to understand, it's straightforward to the point. Of course, it's just like a normal JavaScript object for us JavaScript developers. Now, why JSON is pretty much used everywhere. So JSON is simply everywhere, from being the most crucial part of transmitting data between a normal client and a server like HTTP client and HTTP server, to making app configurations easy, we use configuration or JSON to configure applications or libraries or tools everywhere pretty much, or for even basically storing database data for stuff like MongoDB. And it's simply loved and actually used everywhere because it's an interchange format that can literally be used anywhere and very easy to be integrated because it could be easily debugged. And that's simply because, it has a very human friendly format that can be very readable. Anybody from JavaScript or anywhere and can easily understand exactly what a JSON is and, what the values are and what is it saying. Now, the third thing we gotta need to know about JSON is actually how a simple JSON object is being transmitted over a network. And for example, we're going to take the most famous example around the web and where JSON is particularly used most of the times is between a client, for example, a browser, and a web server communication. So let's say we've got this simple web browser in here. I'm using the web browser in here and I want to actually send a message to my friend. So let's say I'm using WhatsApp or Telegram or any other sort of chat application, or I'm building my own, and I want to simply just send a message to my friend. So of course, for sending a message to your friend, it basically needs to go through and actually reach the server, and from the server it goes to your friend's client, whether a mobile phone, browser, or anything. So when you first start or initiate the message sending in here, so you send a message to your friend, this is basically the data you're basically going to send. So you're going to send it, in here, let's say you're having JavaScript, so you send a normal data object in here with message and recipient ID. The second most important part here, in order for that data in here to be, sent over the server, because that data needs to be encoded as a JSON string, otherwise it cannot be transmitted. So it goes through the JSON encoding in here. For the JSON encoding, it basically uses the standard JSON namespace in here to access the stringify method, and you just simply pass it the data. After you're doing that, of course, this one's gonna return for you a string, a JSON stringified or JSON encoded string particularly. So either you can say encoded or serialized, both of them are the same thing. This is basically what you're gonna get in here, just like the normal object, but more of like in a string format, and it's going to be reaching the server after that. Of course, the server, when he's trying to respond, is going to do basically the same thing. So when he tries to respond in here, when he tries to respond with an object data, he serializes that data in here. So he encodes the data, the JSON, to send the response back to the client. Then the client, in order to access that same thing, he simply just goes do like JSON decode, which is going to use the JSON parse method to parse that data, and he simply just receive his data. As simple as that. So both of these parts actually need encoded and decoded. And this is actually the most important part of the whole thing, because any JSON data in here, if you have like a because this one is very small objects, but let's say you want to send a very huge piece of data over the network, that it needs to be encoded, a JSON encode, which means it's going to be needed to convert it into a JSON string in order to be transmitted and sent to the server, and the server is going to decode it later on in order to access that piece of data. Well, that's basically the issue with JSON. So the JSON stringify in here and the JSON parse for both of encoding and decoding can make the process in here slower, and particularly can make JSON slower by itself. So of course it depends on the type of data. If you have a very small data in here, I think it would work perfectly, but if you have a very long data or a very big object in here you want to transfer over JSON, the encoding process is going to take longer than expected, and thus the parsing process is going to take even longer, and that somehow makes JSON a little bit slower in some scenarios. So right now there's actually many protocols that are way much performant in some case scenarios, not all the time, compared to the JSON. And one of the most go-to protocol, the best protocol made by Google that, you know, most of the teams actually tend to use after they move out of JSON just to make things go faster and more performant, is the protobuf. So the protobuf in here is just a protocol developed by Google, and basically it's being used from Google stuff like Google Maps, inside of Google servers, basically just to make Google's sort of services feel and work faster. And there are actually other protocols like the flat buffers made by Google as well, just to fix some flaws in protobuf and basically like more of like memory efficient. There is the MongoDB BASON. It's not JSON, it's BASON. It's like the same thing. It uses for, you know, encoding and decoding like sort of JSON, but it more of like encodes it into a binary data. And this is more of like used for MongoDB. So MongoDB stores the data in a BASON format. And there is actually another one where it's like the V8, where of course the official Google's JavaScript V8 engine in here, it actually has a low-level methods for serialization and deserialization, basically the same like encoding and decoding for the JSON, of course. So of course, each protocol in here has different limitations, has different use case scenarios and everything, and has of course different performance. For instance, let's pick up the protobuf, which is the most famous one in here. It actually uses a schema-based sort of encoding or serialization. An example of a schema is something like this, where you define exactly how your JSON looks like. So you give it like, you know, the type of the stuff. So you type in like string, uint32, booleans and stuff, and you tell it exactly what's happening. And of course you can nest stuff, you can do a lot of stuff, but this is more of a schema thing. So it's kind of like types and everything. So this is pretty good, and it's pretty solid. But of course, you have to define a schema every single time you want to encode your JSON data. There's actually another library called JS Binary, where it basically uses the same thing, but actually it allows you to convert your JSONs into a binary data through JavaScript, of course. And of course, it uses another schema in here. It allows you to use schema with types and everything. This is actually a pretty good one, but I haven't seen it to be that performant anyway. So we actually did run a benchmark among a lot of libraries, or particularly like protocols from JSON to protobuf, V8, and so much more. And we actually did the deserialization benchmark and the serialization benchmark as well. So in here, if you just go inside of like, you know, benchmarks, there's actually many of them. And for instance, in here we have like, JSON parse. This is sort of another different protocol used for unpacking and depacking, or encoding and decoding. There's like AVSC as well, which is another really good protocol in here. There's the JavaScript binary in here, the V8, the protobuf in here, BASON and Bazer. So all of those are different protocols. You can search about them. I'm not going to go every single detail about every single one. I'm going to just only care about the most frequently used. And for benchmarking, this is actually the results. So if we run the benchmark, we're going to have like protobuf decode, where operations are like more than 400 operations for the deserialization or the decoding. So protobuf is basically the first one and the most like performance one in here, the fastest one with, the more operations obviously is going to be the fastest one. Then there's AVSC from buffer in here, the second one, and right after that there's the JSON bars. And of course, if you just take a quick look into these, there is actually much of difference between this like 900 and this is 1400. So this is actually a huge difference between both of these. Now, if we look further in here into the serialization part, see in here type serialization, we're gonna find JSON stringify is actually the most performance or the fastest one among all of them. So it's like 1700 operations in here. The V8 serialize is the next one, like 1600. There's the message block R pack in here, 900, and there's the encode or protobuf encode, which is the fourth one. So encoding in protobuf isn't really that great, but JSON stringify is literally the best one. But of course, this isn't actually guaranteed all the time. You're not gonna always find that JSON stringify is gonna be the best one for serialization, where protobuf is not, and vice versa. It all actually depends on the type of data that you're basically serializing or encoding. So for instance, for our benchmark in here, the data we're using, if you head over to the data in here, go to get all, which is a very huge array of like objects in here with different like email, gender. And if you just take a quick look in every single one of these are mostly string sort of data. So basically the ID is string, the first name, last name, email, gender, everything is string but two properties in here or something. So most of the data in here is strings. And there's actually one rule that when you're dealing with strings, a lot of strings actually, so JSON stringify in here is going to be the best one because it's the most optimized for strings. But if you actually deal with a different type of data or a smaller object, protobuf is going to win. So to test that theory, we have another benchmark called benchmark-1.javascript in here. And this one basically uses a different type of data where this get one JSON, where it basically has a single object, still mostly like strings, but not a lot of strings, well, one single sort of like objects in here. And when we did basically the comparison or the benchmark between both, for the deserialization in here, protobuf is still the first one in here with like, I don't know how to read that number, but a huge number of operations, which made it super fast for a small type of data. And JSON parsing is like the third one. And if you take the serialization, protobuf is basically the first one as well, because it's a very small part of data and it made an absolutely huge improvement in here, and the performance is just crazy and unbeatable. And again, the JSON stringify is the third one right after the AVSC. Now, a different benchmark we can actually run between the different protocols in here to see how efficient they are is actually comparing the length of the outputs of each protocol. For example, in here for the JSON stringify, when you pass your like a normal JSON with this like output size, for example, this JSON with message, recipient ID, date, and is read, which is a boolean. If you pass it through to the stringify, like what is the exact length of the encoded string that is returned by that method? And of course, we can compare it to every single one of the others, where like the proto, when we run it through like, or the protobuf in here, when we run it through the encode, the baseline in here, when we convert like run it through the encode, because this one returns more of like a serialized, where it's a buffer or a binary data, so we turn it into hexadecimal to make it more of like a string thing that can be transmitted very easily, of course. And the V8 in here, last but not least. And if you take a quick look on the comparison here, the benchmark, so we got this tempo in here where the name, length, and the value. So the name in here, JSON stringify, for that particular payload or this particular JSON in here, it actually did do 105 for the length, and this is basically the value put us. Now for the protobuf in here, the protobuf encode, it has more of like 56, and this is basically the value. It's more of like a mix of a string and sort of like hexadecimal sort of representation of the different bytes in here, which is pretty good. I think it's actually 56 is pretty good compared to the JSON stringify. Baseline and V8 are not doing really great. They're both of them more than 200 like characters in length, which isn't really that great. But if you compare the protobuf in here to the JSON stringify, it's more of like half size of it, right? So it's like 2 times smaller, which I think this is actually another great thing why most people actually tend to use protobuf for sort of like applications where they tend to only send small pieces of payloads, and actually to make it faster for, both encoding and decoding, plus for those kind of like microservices that runs on a cloud or something, for quickly receiving data, decoding it, and actually, preparing or basically handling that piece of data. So that's why most of the teams that actually require that sort of like performance and basically need it are most of them actually moving to a protobuf in here instead of like keeping it with a JSON stringify. But again, JSON stringify is still really great in here compared to, you know, all the stuff that's happening behind the scenes. It does actually handle stuff really well, and sometimes, as you've seen before, JSON stringify can actually even be the protobuf in here in most case scenarios when you have a lot of strings. So for example, there is a case study from AUTH0, which is a leading authentication sort of platform that allows you to authenticate different stuff with different ways, and actually has a blog post of why they moved from JSON to protobuf in here. And this is basically the blog post that compares the JSON performance with protobuf. And actually this one has basically all of, you know, the ideas you need to know, what they found out, why they moved to protobuf instead of JSON, and so much more. Now, JSON is pretty good, but sometimes it could be very dangerous, and it could be ugly when it comes to transmitting a lot of like big JSON data. So what is the best way to basically avoid that, and what is the best way to fix our JSONs and continuous JSONs for better performance? So inside of the same repository in here, I have a folder called How to Fix JSON. So if you click on it, you're gonna find 3 nested folders in here. So the first most important part in here is actually avoid nested objects. So if you open it up, I have a bad approach in here. So there's actually a bad JSON, which is having a lot of nested objects, for example, user, profile, then inside of it there's personal info. All of these are actually not needed or unnecessary sort of nestings that you basically don't need to do. You put the profile, then you put the personal info in here, and have like, you know, name, age, address. All of these are sort of unnecessary and can be very much avoided for more or better performance using JSONs when you send that over the network to your server or send it from the server back to your clients. So the good approach in here will showcase that you can actually turn this into something like this, where you can just, you know, instead of whole nested in here, you can just do username, user age, user street in here, user position, user company, and company location. All the information here, literally all the information, is pretty much in this one with a couple of different properties in here that are very accurate and straight to the point, and again, very performant as well. Another one where is basically using less expressive names in here inside of your JSONs in here. So instead of like, for example, doing, you know, client, geo client in here, location, you do, oh, latitude, location of client, or longitude, location of client, which is a very descriptive and very long name. Of course, this is a pretty good name, but only put that name inside of your source code because it makes sense. But inside of your JSON, you want to send it as a payload. I don't think it would actually make a lot of sense. So instead of doing that much of descriptive name, you could easily just switch it up to something like this, lat and lone in here, and that's pretty much going to save you a lot of space and a lot of bandwidth as well. The third one is actually only transfer what you basically need. So for example, the bad approach in here, for example, you have a lot of stuff. The user has a lot of properties from ID, address, is subscribed, is premium user, last login, other unnecessary field 1 and other necessary field 2. So there's actually so much, or basically so many fields inside of your user. That's pretty good. But when it comes to sending data through the network, whether from the server or the client, only send the necessary stuff. Don't actually send, for example, this, you know, other necessary field 2, or for example, if you don't need to know if the user is subscribed or not, don't send it. So for example, for the good one here, it's much clearer exactly what the server needs. So we only send, you know, the JSON payload that we need with only the properties that are actually needed and going to be used without that much of cumbersome. And that's going to save us a lot of bandwidth as well. And it's going to make it, again, performance. So there's actually so many ways you can actually avoid having long JSONs or very big JSONs in here, and just to make them a little smaller for more performance. And you can just find some tricks to actually fixing your, you know, JSON payloads in your applications and stuff, and that could make a significant difference. So again, JSON for me is still pretty good sort of protocol that I'm basically going to continue to use unless I need that much of performance that, for example, protobuf can provide for microservices or clouds or a specific sort of like application type or application situation that I need. Other than that, I'm just going to keep using JSON because it's pretty good, it's human readable, easy to debug, and it's not going to make me have hard time when I work and develop my applications. And pretty much it's actually supported everywhere, so everyone's going to continue using and loving JSON. But of course, as we've seen before, it's a little bit slower when it comes to some case scenarios. And of course, we have got other solutions we can actually switch between, like protobuf or the V8 serialization for binary data. There's so many options actually are available to fix and overcome the performance flaws in specific situations. But anyway, see you guys hopefully in the next ones.